All right, now let's take what we've learned so far with the right triangle trig with our trig ratios, and let's start building towards that unit circle, the trigonometry main part of this course. So what we're going to do right now is we're going to use our trig ratios to take 30 degrees, 45 degrees, and 60 degree triangles. Now, we usually call these 30, 60, 90 triangles, 45, 45, 90 triangles, and this one is 30, 60, 90 triangle. Now, I know that the first one and the last one, you're like, they have the same name, but they have different angle numbers at the different angle measures at the bottom. But remember, a triangle is 180 degrees, so this angle measure up here is 60, and this angle measured up here on the last one is 30 to make it a total of 180 degrees. So we'll see the similarities between the first triangle and the last triangle and what's consistent in the middle triangle. Now what we're going to use is our trig ratios. Now remember, we're going to find the side lengths. If we find side lengths, we just use the plain old sine, cosine, and tangent. So to find y, we're going to use opposite and hypotenuse. So, ka, toa. So if we're using opposite and hypotenuse, that's going to be the sine. So the sine from 30 degrees is going to equal y divided by 1. To get rid of our 1, or that y divided by 1 is just y. So the sine of 30 degrees equals y. Now, pulling up our calculator, so what is the sine of 30 degrees? We're in degrees. Sine, clear that out, I got to go backwards, 30, and hit sine, we get 0.5. So y equals 0.5. Now, remember that that's also the fraction of 1/2. Now, if we find our next side length, which is x, here we have our adjacent side and our hypotenuse. So to find this, we would use adjacent and hypotenuse cosine. So the cosine from 30 degrees will equal x divided by 1. Well, that's just the cosine of 30. Write that better for you. The cosine of 30 degrees equals x. Going back to our calculator, clear, 30 cosine gives us 0.8860. So here we would have x equals 0.88. Let me go back, 0.8660. So that one's pretty tough to say, oh, what is the fraction? So we're just going to put a question mark. What is the fraction there? So let's skip the middle for a second, because I like to keep things grouped together. Well, let's go over this last one where we have 60 degrees. So if I find x here from 60 degrees, that's going to be adjacent and hypotenuse. Adjacent and hypotenuse is the cosine of 60 degrees is going to equal x over 1. Well, that's going to be the cosine of 60 degrees is going to equal x. Well, what is x going to equal? Well, let's look at the calculator. Now I'm clearing out, so make sure you notice that it's clear, and I'm just going to hit 60, and I'm going to hit the cosine. That gave me 1/2. Well, let's look at y. Y is going to be the sine of 60 degrees is going to equal y divided by 1. So the sine of 60 degrees is going to equal y. Well, let's see what happens when I plug in y here. Clear it out. 60 sine, I get 0.8660. Well, should that happen? Absolutely. Because remember, look at the two triangles. If we switch the angle measures, we would switch the spots of x and y. Look at your values. Here we have y equals 0.5 or 1/2. Here we have x equals 0.5 or 1/2. That should happen. And that pattern we'll use later on. Now, let's go into the middle and work out our 45. So to solve for x, we will take, that's our adjacent and our hypotenuse. So that would be the cosine of 45 degrees equals x over 1. So the cosine of 45 degrees equals x. X is going to equal, go to our calculator, clear, 45 cosine, and we get 0.70710. So I'm just going to go 0.7071. So 7071. Okay. And if I take the sine of 45 degrees, so I have y, this is opposite, and my hypotenuse, I will have y divided by 1. So again, that's just going to be the sine of 45 equals y. Clear out our calculator, 45, hit sine. We get the same answer. So we get 0.7071. Now, in math, a lot of times, decimals are rounded. So a lot of math teachers, we don't really like decimals a lot. We like the fractions. So how are we going to get fractions out of some of these decimals that aren't easy? Well, that's why we're going to do it a second method. And this method, from using previous knowledge, is going to give us better answers because they're going to be more exact because we can write them in fraction form. Now, do we remember how to solve a 30, 60, 90 triangle by the ratio of the side lengths? Remember, when we talked about ratio of side lengths, we had 2a, a square roots of 3, and a. And that ratio of sides would allow us to quickly solve this out. So since we know that this side length, the hypotenuse, has a length of 1, but it has a ratio of 2a, we can solve for a. So here we have 2a equals 1. A is going to equal 1/2. So, well, what side length has a length of a? Well, a is here, so a is 1/2. Substitute a into here, and we get 1/2 square roots of 3. Well, x equaling 1/2 square roots of 3, we don't usually write it in that way. We'll write it as the square root of 3 over 2. So x equals the square root of 3 over 2, and y equals 1/2. So that decimal we got on that previous problem, that I said, what is this decimal here? Well, that's the square root of 3 over 2 for our fraction. Now, what's our fractions going to be for that 45, 45, 90 degree triangle? We remember these ratios. A square roots of 2. So we have a square roots of 2 equals 1. Well, that means a equals 1 divided by the square root of 2. Now, we need to rationalize that denominator, so we need to multiply by the square root of 2 and the square root of 2 on the top and bottom, or on the numerator and denominator. So we're going to get the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. Well, we have what a equals. Well, A equals the square root of 2 over 2. A equals the square root of 2 over 2. So then that tells me x equals the square root of 2 over 2 and y equals the square root of 2 over 2. So going backwards, what decimal is 0.7071 and it went on? That is the square root of 2 over 2, the square root of 2 over 2. Now, since we already worked out the triangle on the left-hand side, remembering back, can you go ahead and plug in what's going to happen over here on the angle measure that's here with 60? Well, remember this is 30 degrees up here. So right in my ratio, my hypotenuse is 2a. The side length between the right angle and 30 degrees is a square roots of 3. And between the right angle and 60 degrees is a. So here again, 2a equals 1, a equals 1/2. So here we get 1/2, and here I get the square root of 3 over 2. Now, if you need to, go by that scroll bar or rewind a little bit and go back through this a couple times if those ratios of 30, 60, 90 and 45, 45, 90 you need a little bit more practice with. Now, what we're going to do now is start building this unit circle, because a unit circle is made up by 30, 60, 90, and 45, 45, 90 degree triangles. Now, we're going to watch a video and watch a lesson building the whole unit circle, but we're just going to take the concepts of 30, 60, 90, and 45, 45, 90 today. So, what we should think about is listing all those angle measures going around that have 30, 60, 90 going around a circle. Another way to think about it as you fill in those, and I'll check that in class, so you need to have that done tonight, and I'll check it tomorrow, is thinking about our axis, our x-axis and our y-axis. If I take this bottom triangle here, and that's 30 degrees from the x-axis, we take the middle triangle here, and that angle measure here would be 45 degrees. And I take this third triangle, and from the x-axis, that's 60 degrees. We just made our 30, 45, and 60 degree triangles. Now, we could label out our side lengths just like we just did. If I take that 30 degree triangle and we label it out and say our hypotenuse is 1, well, what's our side length going to be? Well, this side is 1/2. Look back in your notes. This side length there is the square root of 3 over 2. So our x-axis and going our y's. Going along the x and going up the y. Well, if we keep going with this and we make our 45 degree triangle have a hypotenuse of 1. Remember, that was just the square root of 2 over 2 and the square root of 2 over 2, x equaling and y equaling. Now, looking at our 60 degree triangle, thinking about it being on a coordinate plane, or our x and y axis, a hypotenuse of 1, we get 1/2 and the square root of 3 over 2 for our x and our y. Now, before I move to the other slide, what happens if I take these angles and I put them in quadrant 2? Well, we're moving from the x-axis. So moving up from the x-axis, that's 30 degrees. Moving up from the x-axis, that's 45 degrees. Moving up from the x-axis, this triangle would be 60 degrees. Now, what would those lengths for those sides, what are they going to be? Now remember, our x here is positive, our y here is positive. Here our x here is going to be negative, our y here is going to be positive. So fill that in and bring it into class, and we're going to go over it as our warm-up. But I have two more situations I want you to add to that warm-up. Looking at quadrant 3, moving from the x-axis again, going down 30 degrees, going down 45 degrees, going down 60 degrees. What are the side lengths of each of those triangles for x and y? Remembering, x's are negative and y's are negative in those quadrants. And the last assignment I want you to have done for tomorrow is our fourth quadrant of 30 degrees from our x-axis, 45 degrees, and from our x-axis, 60 degrees. What are our x and y values? Remembering, x's are positive, y's are negative, so put the correct signs with them. I'll check that in the morning. When you come into class, please have it listed out. Draw out the x and y axis as you do it and label them together, and we'll move on to building the unit circle as this is our foundation. Great job. See you in the morning.